Good evening, everyone. Everyone got pizza? All right. Welcome to the DFW Front-End Development User Group. I'm one of the organizers. We have, I hope this mic works.
Yeah.
Okay. So if you have any, if you need any help or if you have any feedback, suggestions, please do let us know. Any one of us. We want to hear from you, that we can improve, and then the topics of interest, anything, any suggestion you want to give. We would like to thank our sponsors, Thomson Reuters, for providing us the facility, food, and supporting us with the door prizes. And we would like to thank Manning Publications for supporting us with door prizes. So we have got two $25 Amazon gift cards and two ebook vouchers from Manning Publications. So everybody got one of the raffle tickets, right? So if anybody has not, please pick it up from here. So
If you haven't, I'll get you in a minute.
Yeah, we have the raffle at the end, and we'll give away the door prizes. Today's talk is given by Brian Sullivan. Topic is tomorrow's JavaScript today. Brian is principal software engineer and consultant with ClearMeasure. He's a Microsoft MVP as well. He has been working with Microsoft technologies from the .NET 1.1 ages, and also he has been working a lot on the front-end technologies and frameworks, and he's interested in introducing the front-end technologies with the clients he's working with. So without much ado, over to you, Brian.
All right. Can everybody hear me okay?
Yep.
All right, good deal. Okay. Let's go ahead. They asked me to record this, so we are going to go ahead and start that up really quick. All right, we should be going now. Okay, as Satya said, today we are going to be talking about tomorrow's JavaScript today, using ECMAScript 2015 with the Babel.js transpiler. So a little bit about me. Satya pretty much already covered that. Principal engineer with ClearMeasure, Microsoft MVP, and ASP.NET IS. A couple of different ways to get a hold of me. If you guys think of any questions, I'll put this slide back up at the end. You guys can write down my contact info, shoot me an email or something. I'd be happy to answer any questions you have. So before we start talking about the future of JavaScript, it's helpful, I think, to have an idea of where we've come from, where ECMAScript slash JavaScript got its start, to put the new stuff in context. So the first version of JavaScript, ECMAScript was ES1, introduced in 1997. So this was very shortly after the initial version of JavaScript debuted in the Netscape browser. So really, this was just a formalization of the language that was introduced there. ECMAScript 2, really nothing much to speak of there, just a few minor tweaks to the language specification itself. ECMAScript 3, on the other hand, brought a couple of improvements. Regular expressions were now built into the language, try-catch syntax, and some things around string handling. So definitely an incremental sort of release. Now, almost directly after that, work on ECMAScript 4 began. Now, unfortunately, what ended up happening with this was a lot of infighting among the members of the committee that were trying to design this new language. They were trying to introduce a lot of new features like classes and modules, optional static typing, which will sound very strange to somebody who's used to JavaScript programming. But a lot of these topics were very contentious, and so we ended up not having a revision of ECMAScript for a good long while. And we, at about 2000, enter into which is essentially a dark age of JavaScript. There's not a whole lot going on. And it sort of stagnates, and we end up with this language that's sort of used to do a little bit of client-side validation and not a whole lot else. Now, Ajax, not a feature of ECMAScript per se, not a new version of the language, but this formalization of these techniques for asynchronous communication with servers does mark a point at which there's sort of a renaissance of JavaScript development. We can start to do a whole lot more interesting stuff with the language now that we can talk to servers in addition to running within the browser. So several more years pass, quite a bit of time in the tech space. But eventually, the committee gets their stuff together, and they start working on something that they initially call ECMAScript 3.1. And this was a much more modest revision to the language. Really just some stuff around strict mode, getters and setters, native support for JSON, and a lot of the things that were originally part of ECMAScript 4, which was completely mothballed, were made a part of something called the Harmony project, which leads into what we get with ECMAScript 6. Still 6 years after the introduction of ECMAScript 5, still quite a long time, but at least now we are getting some of the neat things that were promised way back in 2000. So, and it was officially ratified this year, so ECMAScript 2015 is an official standard. Now it's just up to the browsers to actually implement all of these new features. So, what are we getting with ECMAScript 2015? There are some enhancements to built-in objects, and we'll go over some of these in a little more detail. Some enhancements to the way variables and parameters are used and declared, an optional class syntax, as well as arrow functions. That's actually what they're called in the language specification. You may know them better from C# or Java as lambda expressions. And also a badly needed module system. So, what are we getting in the built-in objects? So, number is getting quite a few enhancements. If you'll remember, JavaScript doesn't have separate integer and floating point types. There's just number, right? So, because of that, it's helpful to have a method that tells you whether a number is an integer or not, right? Is safe integer? It's a little bit interesting. JavaScript can actually only store integers up to 2 to the 53rd power minus 1. If you start to get integers bigger than that, it only is able to represent one integer every 2 mathematical integers. So you'll start to see some really wonky stuff if you get into using numbers that big. I've never had the occasion to run into those problems, but if you do, something like this is helpful. And just a couple of different other things here. You'll notice parseInt and parsefloat. You'll say, don't we already have those? Well, they're actually global functions right now in JavaScript, but the committee is trying to get away from that global scoping of a bunch of different stuff. So it is instead hanging them off of the number, and that's sort of the recommended way to use those going forward. Also some enhancements to the math object. Lots of trigonometric stuff here. I've never had to do trigonometry in JavaScript, but maybe if you're doing some graphical stuff, maybe that might be helpful. Array. These are probably a little more helpful. Find is particularly nice. That takes in a callback function which will return a Boolean result indicating whether a particular member of that array matches a certain criteria. So it's like a where expression, if you will. And same thing for find index. Obviously, it just gets you the index into the array, just like find would. Some of these are a little more niche. From is a little interesting. That is takes an array-like object and turns it into an actual array. So there are some things in JavaScript, like the arguments object that you get whenever you call a function. It looks kind of like an array, but it's not actually an array, so it doesn't have all the methods that an array would normally have on it. So if you get one of those things, you can pass it to array.from, and now you've got a real array that you can do fancy operations on. Some enhancements to string, starts with, ends with. You could have written these essentially yourself with index of and that kind of thing, but it's nice to have these available without you having to write them yourself. Repeat and includes are pretty self-explanatory. Also getting native support for promises. So no need for libraries like Q or anything like that anymore. Now we've got sort of this, what's become sort of the standard promise syntax in most promise libraries is now going to be included in the language by default. We're also getting some new collection types. So proper sets, so that means in the mathematical sense, right? If you try and insert the same object into a set twice, it'll throw an error, so you can't do that. Map, you might say, well, we sort of have this already, don't we? Aren't JavaScript objects essentially maps? We've got a string key to get into to get any sort of arbitrary object. Well, maps will actually let you use any sort of arbitrary object as the key, not just as the value inside that map. Weak sets and weak maps are useful when doing things like when you're dealing with DOM elements, because they do not prevent the objects within them from being garbage collected. So if you stick a DOM element, say, inside a regular set or map, you could end up with some higher memory usage than you might otherwise. So very useful there. Okay, so with that, we're actually going to start to look at some code. Now, the best way to demo new features in a language, it's sort of hard to demo new language features and come up with an actual application. It ends up feeling kind of contrived. So what we're going to do instead is write some unit tests and sort of describe how we think these language features work and see those proven out. So we've got a project already set up here, but we're going to need a couple of tools to get going here. Now, I mentioned right at the very beginning that we're going to be using something called Babel. So I'll take you to the Babel.js site here. Now, what this is going to do, Babel will take your ES 2015 code and turn that into ES5 code, so code that will run in just about any modern browser. Well, and what does modern mean, right? Well, definitely anything IE 9 and above. You can start to run into a few problems with IE 8, but there are some workarounds that if you really do need to support that. If you're supporting IE 7 and below, I'm sorry, but maybe ES15 is not quite for you yet. So there are multiple different ways that you can use the Babel transpiler, and they've got tutorials on lots of different build tools, lots of different module systems, all of these different things that Babel can hook into. We're only going to use one of them because we don't really have time to cover all this other stuff. So we're going to be using Gulp, which is a JavaScript build system, and a Babel-specific plugin for Gulp called Gulp Babel. So let's go ahead and install those into our project. And that will get us Gulp. And we also want Gulp Babel. And in previous versions of this presentation, I haven't had to do this next step before, but with version 6 of Babel, things have changed, and the Babel package by itself doesn't actually come with any functionality, which seems weird, but there are presets of plugins that will essentially get you the out-of-box functionality that you were used to having with previous versions. And so we're going to grab Babel preset ES 2015. Actually, that should have been save dev with all of these. I don't guess it matters a whole lot, but taking a little bit longer to download. All right, we can go ahead and jump over to WebStorm. So we're also going to want to set up a gulp file. So this is going to be our build script, essentially. So we'll create a new JavaScript file. This will be called gulp file. And I have got a snippet set up for this. And we'll go ahead and paste that in there. And also new with this new version of Babel is a new file that's going to be required. And I think it's called Babel RC. This is going to be essentially a JSON file, and we're going to tell it what presets we want. In this case, it's just ES 2015. Oop. All right. So now, hopefully, that will have finished downloading. Yes. All right. So let's explain this just a little bit first. So the main task in here is going to be this scripts task. So what this is doing is looking for any file in the specs folder that's got a JS extension, piping that to the Babel transpiler. So all of these files, grab them into one, shoot them into the compiler, and then spit out the resulting ES5 code into the dist folder. We've also got a watch task set up here. Oh, that's nice, new macOS feature. A watch task that will look at the directory and see every time we change one of those files, it will automatically do the recompilation for us. So let's go ahead and start that up. We're also going to want a web server. We're going to be using the Jasmine test runner, and that's just hosted in a web page that we've got, a static HTML page that we've got here. All right? Okay. So now let's go ahead and create that specs folder that we're looking for in our build file, and we're going to start off with some of the variable enhancements that I was talking about before. So we'll call this file variable specs. And this is just some Jasmine syntax here. So we're going to describe our test suite. So this is our variable specs and a function that will contain them. All right. So now, let's see, do we need to stop and restart this? Okay, we do have a dist folder now. Awesome. All right, and so we'll go ahead and bring up localhost 8080 spec runner. Okay, no, we don't have any tests going right now, so it's blank. All right, so the first thing we're going to cover is the new let keyword. So this is essentially a replacement for var. Now, why do we need a new way to declare variables? Well, right now, variables in JavaScript are function scoped. So if I have something like, I'm going to go ahead and start writing a test here. Should use let. If I've got a for loop, say, and I've got var I equals 0, I less than 5, I plus plus. We don't really need to do anything in there. And then I say expect I to be 5. This is actually going to pass. We'll go back here and verify that it does. Uh-oh. Do we not? Oh, that's also because we did not include the output as a script tag in our page. We need to do that. So we'll do dist variable specs. All right. Now we should be good. Okay. So contrary to the way it might work in other languages, this var, this I here, is actually being hoisted up to being defined at the beginning of that function. So we didn't have, these are not block scoped variables. We can't, we have to be very conscious of things that we declare inside for loops and stuff, because they're going to be accessible at the function level. Now, if we instead change this to let and refresh, we're actually going to get an error. It's going to say I is not defined, which is, it looks like it's an error, but this is actually behavior we want, right? Because this makes our code easier to reason about and less error prone, right? So the standard going forward, the advice of JavaScript wonks everywhere is to use let for anything, anything and everything, pretty much, just because it is safer. All right, so we are going to go ahead and comment out that that test, because it is going to continue to fail on us. All right, so we are also getting a const keyword. And this works exactly how you might expect. So say we have a constant called pi equal to 3.14159, and we'd expect pi to have that same value, right? Come back here and refresh. Const works like that. And if we try and assign pi something else, you can see our editor here is even getting us, giving us a little bit of feedback there, and the transpiler actually crashes. So not the friendliest of responses, but it does get the message across, right? And it does give you some helpful messages here. It's pointing right at the code that it tried to compile that it couldn't. So we take that back out. We should get the behavior we expect. Okay. Now, let's move on to something else, something a little more interesting called destructuring. So this is a feature that's available both for objects and arrays. We'll start with arrays. All right, so say we've got an array named A. We'll just declare it using the array literal syntax there. We can now say, if we wanted to have variables B and C that were equal to the first and second elements in that array, we would normally have to write two different statements with an array index syntax to grab the first and second element out of it. But with destructuring, what we can actually do is say let B, C equal A. So that is going to positionally pull elements out of that array and assign them to those variables. So now we can expect but B to be equal to 1 and C to be equal to 2. If we refresh, we have not recompiled yet. Oh, that's right. I didn't start gulp back up. All right. Cool. So we can also take a look at the output here. One of the things that the Babel team strives for is to have as humanly readable output as possible. So a lot of the code that you get output of Babel, you're going to be able to reason about very easily, which is great because this is actually the code that's going to be running in your browser. And if you're debugging, then especially if you're not using source maps, then this is the code that you're going to be stepping through, right? So, and this does exactly what you might expect, the way we can already grab elements out of an array. And if we go over any features here where you'd like to see the ES5 output, just raise your hand, let me know, and we can do that. Okay, so I mentioned that it also works for objects. So let's see that. So say we have an object A with properties B and C that have the values 1 and 2. We can now declare properties X and Y that pull the values of B and C by doing this. B goes into X and C goes into Y. All right. So I don't know about you, but that feels a little backwards to me. I would have thought that the variables went the other way around, but unfortunately, this is the syntax we got. So we just have to learn to we have to remember it. Okay, so we can then write some expectations here. X we expect to be equal to 1, and Y to be equal to 2. And if we refresh, nope. So sometimes you can see this is not the code I wrote, right? I paused in the middle to say something. It's one disadvantage to having the transpiler run constantly, just be watching the file system for when things change, especially when your editor automatically saves the file as you type. You'll eventually get into this sort of situation where it saves it and you weren't quite ready for it yet, and that'll crash your transpiler. So another option is just to run it manually whenever you're done making changes. All right. So now if we, oops. Whoa. There we go. Okay. That test is now passing. Okay. We can actually do the same thing to function parameters. So if we have a function called do something, or actually let's start with the object itself. So we've got, say, a settings object. We'll have a lot of these times when you're dealing with third-party APIs, they'll have these enormous objects. You know, when you're maybe dealing with jQuery and its AJAX libraries and stuff. So you may have something with a URL property, not RUL, but URL. That'll be /foo, and it's got a method that's equal to post, and maybe a ton of other things on this object as well. But perhaps you're only interested in a couple of those properties, right? Maybe this thing has 50 properties on it, but you only really care about 2. So if we have a function called do something where we're passing in the settings object, we can declare that in such a way that we actually yank the property values out of that object. So we can just say URL and method. And now we would expect URL to be /foo and method to be post. All right. So that whole thing sort of distilled down to just 2 variables. Okay, and that test is passing as well. We're also getting another feature related to parameters, something we've had in C# for a little while now, default parameters. And this syntax is very familiar if you're used to C#. So if we have a function, myfunc, which has a parameter foo, we can set its default by using the equal sign. That's going to be equal to bar unless we pass something into it. So here to test this, we'll just return whatever we ended up getting for foo. And so we would expect myfunc with no parameters to be equal to bar. Oops. And myfunc, when we pass baz, to be equal to baz. All right. Yep. All right. Default params. That's passing now too. Okay. More parameter stuff. There's a new feature that I'm not aware of in languages I've used. There may be somebody may raise their hand and say, "No, we've had that for years in XY language," but this one was a new one on me, called REST params. And this has nothing to do with representational state transfer. This is a language syntax thing. So we can have a function. Again, we'll just call it myfunc. And it'll have parameters 1, 2, and ... rest. Now this thing doesn't have to be named rest. It should be named any arbitrary thing you want. So if we were to call this thing, not function. If we were to invoke it with 1, 2, 3, 4, 5, the first 2 variables here will be passed into parameters 1 and 2. This rest parameter here will be an array containing the remaining elements. So we've been able to do something like this for a long time with the arguments collection that we've got in JavaScript. But again, arguments is a little weird. It's an array-like, but not actually an array. Rest is actually an array object. So we can say that we expect 1 to be 1, and we would say we would expect rest. We have to use a little bit different syntax here. 4, 3, 4, and 5. And to boot, we'll do this. Expect rest to be an instance of array. Right. All right, and all that's passing. So just a slightly more useful way to get parameters to a function that you weren't necessarily expecting. All right, and we also have the sort of opposite of REST params called the spread operator. So we're going to be using this when we invoke the function instead of in the declaration of the function. So let's see. It's a little bit more clear if I can show you. Okay, so say we've got a function that takes 3 parameters. and we've got an array that has the values that we're actually going to want to pass into each of those. So we'll call that my array, and that'll be equal to array literal with the values 1, 2, 3. We can call myfunc. Normally we would have to say something like myArray sub 0, myArray sub 1, etc., right? If we've got an array with those values in it already, we can say ... myArray, and those things will be pulled out one at a time and passed in as those individual parameters. So now we can expect one, to be 1, 2 to be 2, etc. Right? And we are passing there as well. So that's rest params.
So either one of those, if you don't have enough, too many or not enough members in the array.
So too many, I'm not sure. I assume that those would just disappear into the ether, and you might be able to get at it via the arguments object. And for not enough, I would assume that they'd be undefined, just as they would be. So let's take a look at the resulting JavaScript here, and we can probably reason out from that what would happen. Okay, so it's using apply. That's interesting. Cool. I wouldn't have expected that, but so that's what we're getting. And changing that to 3 is not going to change the output of that at all, I wouldn't think. Yeah, no. So essentially, we're getting syntax sugar over apply. So nice. Learn something new. All right. String templates. So again, a feature we've gotten recently in C#, should be pretty straightforward. Let's see, say we have a string name of Brian. We can have a message string. Now, these are delimited by backticks. So, a key up in the upper left corner of your keyboard that you never use. This is going to say hello, dollar, curly brace, variable name. So, a somewhat nicer syntax than just tacking it on with plus signs, right? So in this case, we can expect message to be hello, Brian. All right. Another thing to note here about these backticks is that it also allows for multi-line strings. So this is now valid, where with double quote or single quote strings that wouldn't have been. All right. One more thing with sort of new keywords and stuff is the for of loop. So we've had for in JavaScript for a very long time, but its behavior for somebody who's come from a language that's got for each constructs in it is a little non-intuitive, because the variable that you declare on the left side of the in ends up being an index into the thing on the right side of the in, right? So, for example, if we've got, so we'll have an items array here that's equal to foo, var, and baz. we could have a string, and we're going to loop over these things and just concatenate them onto all items and see what we get out at the end. So if we had a for in loop for I in items, and we tried to do all items plus equals I, and expect that result to be foo bar baz, we are going to be disappointed. Right? We end up with 0, 1, 2. Those are indexes into that array instead of the object at that position in the array instead. So to get something more like a for each loop in Java or C#, we've got a new for of syntax that we can use. And now, if we rerun this, we get a passing test. So this is particularly useful when you've got multiple different levels of arrays, because what you would end up with is my collection 1 sub I dot my collection 2 sub j dot my collection 3, etc. And it would get very long-winded if you had to dig through object hierarchies like that. This makes that quite a bit easier. All right. So with that, we are going to move on to the new class syntax. So before we do that, does anybody have any questions about any of the stuff we've talked about so far? Nope? Okay, great. Let's keep going then. So we'll go ahead and create a new spec file for that. The other one was getting pretty big already. And we'll go ahead and add that to our markup. Okay. So before we actually dive into creating a new class, it's important to know that we are not getting a classical inheritance system in JavaScript. Behind the scenes, this is all still prototypical inheritance. So all of the same things sort of still apply. This is just syntax sugar over the way we already did inheritance in JavaScript. Okay. So let's go ahead and create ourselves a class. So we'll say a class. We'll do the classic 00101 example of a shape. So we can have a test here. Say if we had a variable s equal to new shape, we would expect s to be an instance of shape. And we expect that to be true. Right? All right. Okay, cool. So one thing to note in the output here is this class call check. So if you see the actual definition of shape here, you can see that this is really just a standard old constructor function that we've had in JavaScript forever, right? And we'll get into exactly what a constructor looks like in the new class syntax in a second. But the transpiler has actually inserted this class call check function. One of the downsides to their the way you define a class in JavaScript being the exact same syntax as what you use to define a function is that you could just arbitrarily invoke that function from anywhere, and then all of your thises start assigning things to the global, to the window, and
all heck breaks loose. So this function here, if you try and invoke a class that way, it will actually throw an error because that's not what you want to be doing. All right, so let's look at constructors. So we have a new keyword here called constructor, and so we'll take a width and a height here, and we assign properties exactly the same way we did with constructor functions, which is to hang things off of this. This.height equals height. Okay, and if we were to create a new shape with 5 and 10, we would expect s.width to be 5 and s.height to be 10. All right. And if we refresh, that is now passing as well. So again, going back to the output here, this is same old type of constructor function that we would have written for years. Okay. We can also do subclasses. So if we've got a shape here, perhaps a subclass of shape might be rectangle. And unfortunately, I say as the .NET guy, the Java inheritance syntax won out, so we use extends and not a colon. So now we have a rectangle class that inherits from shape. So if we were to create a new rectangle, we would go ahead and still use the same constructor function from before, but we would expect R to be not only an instance of rectangle, keyboard, but also an instance of shape. All right. Oh, transpiler crashed on us again. Okay. All right. So that's that is passing. So what if we want the a constructor in rectangle as well to take in some maybe additional parameters? Say we wanted all rectangles to have a color. I don't know what is intrinsic about rectangle to have a color, but it's a name to use. So we would want to take width, height, and color. So you notice already that we're getting some red squigglies here, and that's probably a little hard to read from the back, but it's can't even get it to show up. But it's saying we don't have an invocation of the superclasses constructor. So in every constructor inside a subclass, you have to call super and pass it in width and height. Oh, nope. Just a semicolon there. And then at that point, we can say this dot color is equal to color. So we'll just add a couple more expectations to our test here. Expect r dot width to be 5, and expect r dot color to be, say, blue. And we'll add that up here. Again. All right. And we are still passing. So we know that's all working. All right. So if we've got classes, we've got data on them already, but what about defining methods? So that is pretty straightforward. If we want to define a method, say called getArea on rectangle, notice no function keyword at all, just name and parameter list. So we could then return width times height, this dot width times this dot height. And we'll go ahead and write another test. We'll say we'll just copy this from up here. That'll be easier. So we would expect r.getArea to be equal to 50. And that is working. All right, so what if we wanted this to be a property instead, not have to use the, it's not going to take any parameters, so we could just, and we wanted to use it without invoking it with the parentheses. We can do that with getArea. Oops, I didn't do that right. That is actually going to have parentheses, even though it's not going to take any parameters. And we'll return exactly the same thing. And at this point, we could change our invocation here to just be area. Note the no parentheses there. And we are still passing.
Nice.
All right, so with that, let's actually move on to arrow functions. So again, this is a feature we've had in other languages for a while, and JavaScript is sort of notorious for having being just littered with callbacks, right? And we have to write the function keyword so many times, it's kind of a pain. So having a nice shorthand syntax for that is gonna save our RSI for a few more years. So we'll call this arrow function specs. And we'll go ahead and include that in our markup. Arrow function specs. All right. So we'll have our describe block up at the top. Okay, so essentially you can use the new arrow function syntax anywhere that you would have otherwise used the function keyword. So for example, I can invoke it just like a normal function. So we'll have a function called sum that is defined as follows. So these are the two parameters to the function, and this is what we are returning. We can also do the longer hand syntax of having curly braces around the operation that we're doing. In that case, just like in C#, you would want to have a return statement inside there. But if the function you're creating is simple, like this one, you can omit that. And we can set up some expectations here. We can expect sum of 1 and 2 to be 3. Right, and that works. And it is also particularly useful for, like I said before, we've got lots of callbacks in various different JavaScript libraries, so you can use that as if an existing function, library function, expects to receive a function, you can use a lambda expression, or sorry, an arrow function in its place, like so. So say we had, we're just going to do a sum operation here. We'll use one of the methods on array, var. Old habits die hard. Okay, so we've got a numbers array that's equal to 1, 2, 3, 4. We can do numbers dot for each. For each is just a method on array that would normally we would write, function I whatever. But here we can just write n goes to sum plus equals n. All right, and now we would expect sum at the end of that to be 10. Right? So anywhere that expects you to pass in a function, you can pass in an arrow function instead. Right?
I'd like to see the code that one created.
Sure. It really is just syntax sugar, right? Except in one other case, which we are about to get to, and that is the lexical scoping of this. So if you've done asynchronous programming in JavaScript, you'll know that the this keyword can get really squirrely. This can be one thing 1 minute, and you call something asynchronously, and all of a sudden this is the window, right? So let's set up an example here. So we've got a this.val is equal to 5, and out of the scope of this presentation, but Jasmine tests have, in the context inside the test, this is a special object reserved for you to hang properties off of and stuff. It is not the window in this case. So if we were to do something asynchronous like set timeout, and we've got a function here that we do an expectation, say, I just did this, right? I did it before set timeout was run, should be 5, right? That'll be 10 milliseconds. And because we're doing something asynchronous here, in order for the Jasmine test to know that it's finished, we actually have to take in a parameter to our test here called done and invoke that when the asynchronous activity we're doing is through. So we'll invoke it there. So if we run this, you can see that this .val is actually undefined, because in this case, this is equal to the window. We totally lost the this context. So if instead we change this to be an arrow function, this keeps the context of this the same as it is on the outside of that asynchronous invocation. So after this has compiled, we'll see that this is now passing, right? So it may not get JavaScript developers over the PTSD associated with the this keyword, but it is a step in the right direction. Now, if you want to look at the code that generated, it is a bit less. Oh wait, yeah. So it's exactly the same thing as we've been doing for years. I usually use self. A lot of people use that. It's whatever your preference is. But so this is just a sort of nicer way to get that done and not having to worry about keeping that scope around yourself.
And it would do the same thing as bind in that case also?
Yeah, sure. So if you use bind instead, you can specify the this for that asynchronous invocation.
Okay.
Yeah.
It'd be the same as a bind this.
Yeah.
Okay.
Mm-hmm. Yep. That is another technique to getting around the weirdness of this. It's one thing that Brendan Eich is always apologetic for when he speaks at conferences. All right, so that's arrow functions. Oh, we are at 8 o'clock. All right, so wanted to cover module syntax, but I actually need to hit the road. I am driving to Austin tonight, so we'll leave it there. We'll leave modules as an exercise to the reader. I would highly encourage you to look at that though, because that is a really, really crucial part of what's new in ES 2015. The ability to separate out different pieces of our application to be able to tie them back together is something we've been sorely missing in JavaScript. I will mention that Babel by itself is not quite enough. You do need a sort of module shim in addition to the Babel transpiler. The demo that I was going to do uses a tool called Browserify, as well as an add-on to that called Babelify. A little bit hard to say, but it's essentially a Browserify plugin that will do Babel transpilation. So again, highly encourage you to look at that. They've got very detailed instructions on the Babel site for using it in that context. So I'd highly encourage you to check that out. Another thing that we didn't get to cover that I'd recommend you look at is something called generators. So this is something akin to enumerables in C#. Or I think they're iterables in Java, I want to say. So the ability to have the yield keyword and sort of do logic inside something that just looks like a collection. Again, very, very neat stuff, and also opens up some possibilities for really cool async keyword-like behavior. So again, exercises for the listener. I will go ahead and, like I said, put my... Oh, we closed the presentation. I will go ahead and put my contact info back up. And just open it up to any last questions you guys might have. Yeah.
Do you have the final specs that you would have had written at the end of this available somewhere?
Yeah, so those are up. This whole thing is up. All the code plus some extra stuff is out on my GitHub repo. If you look for ES6 presentation, ES 2015 used to be called ES6. You can find it there, as well as sort of. I tried to do stepwise commits so you can see the code sort of as it's being written. I don't think this slide deck is up there, but there's not a whole lot to that you can find pretty easily with a Google search. Anything else?
Good place to go looking for this. I mean, the last one I saw said, here's 350 things that are new that you need to know.
Yeah.
So,
Um,
so article. So, any good ideas?
The Mozilla documentation is always very good. I'm not sure if they've got a bunch of ES6 things documented. I'm not sure if that's all centralized into one place. There's lots of good courseware on like Pluralsight and stuff. I know K. Scott Allen has a great course on this as well. It's able to go into a lot more detail than I'm able to get into in 1 hour. So I definitely recommend that.
I can't think of anything else off the top of my head. I do want to point out one more useful site, the ECMAScript compatibility table. So this will tell you what features are available in what browsers. So you notice here IE10, IE11, Edge, etc., Chrome, and they've got Babel listed separately. So you can notice there's a lot more green in that column than a lot of the others. So this will tell you not only what the browsers natively support, but what the transpilers like Tracer and Babel support as well. And there's also, if you're really advanced, they've already started to track what's supported in ES7 or ES 2016. Anything else?
What's the main difference between TypeScript and
Oh, goodness. So obviously, the optional static typing that is not present in ES 2015. So Anders feels very strongly about static typing, so TypeScript has it. I believe the way you define modules is also a little bit different. But apart from that, it's almost I think one of the goals of the TypeScript team was to take a lot of the proposals almost syntax for syntax that
Coming in the future of JavaScript to make that part of TypeScript so that eventually TypeScript itself just sort of goes away, right? It's identical to what's runnable natively in your browser. So those are the main things: typing and module stuff.
So which one is better? Do you think, like start using TypeScript now and then slowly go towards
That probably depends on your stack, and just really your personal preference. How much you like static typing, I think, is going to be the main differentiator. Like I said, almost everything else except the module definitions are the same, and you can learn to do either way of module definition. So.
If you're coming from a compiled language, you probably want to, just because I mean, you get warnings, which you don't.
Yeah, you do. It's really down to a personal preference thing. What's getting spit out the end is ES5 in either case. So runtime wise, you're not any safer, but if you're bought into static typing and feel like that's a big advantage to your project, then TypeScript is definitely the way to go. Anybody else? All right, thank you guys.
Thank you.